Good morning to all of you. Welcome to our MAT163 Calculus 3. So we thank the Lord for this opportunity. I don't know if my students will come in, but nevertheless, we will continue. Because next week will be the midterm examination. This is week number 11. So there's a necessity for me to discuss something, as I would like to introduce Power Series this morning. Welcome to our week number 11 of Calculus 3. So, I don't know. I don't have a clue if my student will come in. Nevertheless, I will continue on this. And later as well. So we thank the Lord for this time that we could continue. Okay, so let's open the word of prayer. Father in heaven, we thank you for this day. Thank you for this opportunity where we could continue on our discussion, particularly on Power Series. I pray for your mercy and grace, and that also that the student may review this video through the YouTube channel. I pray, Lord, for your guidance, and as he prepare also for the midterm examination next week. This is our prayer in Christ's name. Amen. So let's continue now. So I don't know the reason behind, but nevertheless, tutuloy po tayo. Napakahalaga kasing topic natin about Power Series, no? Ano natin siya about Power Series, no? So we're now on week 11. So this is the Power Series. All right, can you see it? This is the Power Series. We are MAT163. This is for Math Major. If you don't love Math, ayan, mahirapan kayo ma-appreciate itong bagay na ito. As far as our studies concerned, we're now on Power Series. Now, the Power Series is defined by this expansion on a sigma notation form. That's equivalent to summation of a sub n is any constant times the quantity x minus z raised to n, where n is equal to 0 up to positive infinity. Now, if we will try to expand this further, we may create a series, an infinite series. Now, that is of an increasing power. That's why it's called a power series, because there is an increasing power of x minus c for this particular case. And that, if we could expand this such that this may be written as a sub 0, because at x raised to 0 is equal to 1, so there's no component for that first term. Then we have a sub 1. A sub 1 times x minus c raised to 1. So that would maintain, hindi siya nag-announce. Then you have another plus x sub 2 times x minus c squared, etc. and etc. So it will go continuously. Pagtutuloy-tuloy yan. So that is your power series. And of course, in this power series, there is what we call a special case where your c is your power series in x about c with coefficients a sub 1 has an important case when your c is equal to 0. At your constant equal to 0, so that would be a special case that would lead to another type of series, by the way. So there are two. So we have the Maclaurin series and the Taylor series. So these are two important types of power series as far as differentiables or the derivative of a power series is concerned. Let me check my sound check first. Series, by the way. Okay, acknowledging our 3 or 2 top chats from our YouTube channel. Paramdam lang kayo dyan, mga kapatid. So this is for Math Majors Pasensya na. So we could have a similar expression at C is equal to 0. So this would be now summation at n equal to 0 raised to positive infinity. Magic, di ba? So this would be now equal to a sub n times x raised to n would be expanded in terms of a sub 0 plus a sub 1 x plus a sub 2 x squared, etc. and etc. So this will be going through infinity, mga kapatid. So let me check if my student is around already. Not yet. So dapat nandito na rin. Okay lang yan. So tutuloy ko na lang yung aking broadcast even without my student because kailangan ng I cannot delay this lecture because next week would be your midterm and you need the scope of power series in your midterm examination. And by the way, for the record, our midterm exam will be an oral examination. I'll be asking series of questions regarding our topic, starting from sequence and then series, no? And then we have this power series as well. So this would be part of the inclusion. Acknowledging Sir R.C. Pinoy. Salamat, sir. Salamat. Welcome to our Calculus 3 class. This is Calculus 3. We're now discussing power series. My students still have connection issues. But thank you, sir, for dropping by. I know you would love to see these these expressions, no, or mathematical equations, I would say. No? Yan, lakihan pa natin ng konti. Okay, so this would be the definition now. The first one is what we call, that equation would be leading to what we call Maclaurin series later on, sooner or later. The first one, if I would like to put this in letter A, and then this would be letter B, expression. So A will be sooner or later become what we call Maclaurin series. Maclaurin series, Maclaurin. Ano nga ba spelling mo? Ang alam kong ano lang eh. Ano talaga siya. Hindi siya yung McDonald's. Maclaurins. Maclaurin series. And then of course you have your Taylor series. So ang kaibahan nila, mga kapatid, the Maclaurin series at C. So there's a certain value of C, Taylor series at C equal to 0. So yun yung so certain value of C for Maclaurin, and but basically both are the same, similar, no? Similar items here. Okay, so let's move on. Let's have some examples as far as power series is concerned. So for instance, we have your sample series. Say, so if you have, for instance, a classic power series example would be this one. So assuming that you have sigma notation there, at n is equal to 0 up to infinity. Or positive infinity, I would say. Yan. So So x squared, no? X raised to n rather. So this could be expanded into 1. Of course, the first term is 1 plus x squared plus x cubed. Okay, and so on. Ayaw, ano, ba't kaya ganun? Yan. So obviously, this is a geometric sequence. In fact, this is a geometric sequence or geometric series. And we know from our previous study, let me check on my student. Still not yet here. Nasayang naman yung lecture ko. Still a geometric series, no, as you may recall, and that the sum is converging. Now, there's a convergence in the sum such that the limit would be the limit of that sum, or the limit of the ratio. I would say it should be the -1 for the ratio. So we have greater than -1. Ayan, buti natatawa Sir RC. So we have here, so this is the limitation. So there must be a fractional ratio. But obviously, what we have here, no, if so there is a fractional ratio for us to have a series convergent, no? There is a this is what we call the region of convergence. Convergence. Nahihirap ako sa spelling nito. Oo nga, Sir RC, no problem, no problem. Welcome, you're welcome. Convergence. Tama ba? Yan, so region of convergence where there is a defined value. No, there is a defined value for the series. However, if it is beyond the region, we cannot really define the value of that series. And otherwise, it's what we call divergent. Otherwise, it's called divergent. Meaning that is beyond, that's beyond +1 and below or less than -1. That's the limitation or the limit of the region of convergence. No, otherwise, it's called divergent. Divergent. Divergent, no? Dito talaga ako sa spelling nito, ah. So, yun yung makikita natin dyan, no? Ano na lang, gawin ko na lang, converging na lang, yun na lang. Converging, otherwise diverging. Diverging or diverges. Converges. Ibig sabihin, siya ay may definition. So, meron siyang, we could define the series on this particular region. Region of convergent. Converges. It converges, otherwise diverges. So we could have that. All right. So basically, based on the definition of a geometric series, now it follows that the sum or the sum S sub n now would be equal to, based on the definition, would be if the ratio or the common ratio for this is in -r or -1, greater than -1 and less than r, So by definition of geometric series, that would be equal to A sub 0, which is the first term, all over 1 minus R. And since your first term is equal to 1, so that's the definition of a geometric series that is converging. So meaning we could always set a limit for the sum as it approach to a particular numerical value. So meron siyang limitation, no? Meron siyang pag converging, pag divergent, di natin makikita yon. So obviously the first term there on that example is 1 all over 1 minus x, and the ratio is x. All right, so that's the answer. So that's the sum. So the domain, assuming that your C is around 0, so that the domain of the corresponding function is an interval around 0. So at C is equal to 0. Acknowledging, Ma'am Gina Choco, salamat Madam. Thank you Madam for dropping by. Mga kaibigan po natin sa ating live stream, salamat po Ma'am Gina. Thank you for dropping by. Really appreciate your presence Madam. Madam, yung mga luto mo dyan, pinapanood ko. Yan, kasi mahilig lang ako kumain pero hindi ako marunong magluto. Ayan, yung mga content po ni Ma'am Gina. Meron po siya mga content about cooking and other things. Ayan po, si Ma'am Gina Choco. Salamat po, Madam. Thank you for dropping by. I don't know if you will like this topic. This is Calculus 3. So, ibig sabihin, nakalusot ka na ng Calculus 1 and 2. So, Calculus 3 na. Ayan, salamat sa ating 3 top chat sa ating YouTube channel. Alright, tingnan ko yung estudyante ko. Actually, my students from Tugigaraw, there are issues in connection there. So, kaya nga binobroadcast ko to para ano. Oo nga sir, taga-kain lang ako sa bahay. Hindi ako hindi ako cook. Sabi ko pagod na nga utak ko kakaturo ako pa ba magluluto, di ba? So taga-kain lang ako talaga. Ayan, kasi pagod na yung utak natin kakaturo So ganun po yan mga kapatid. Okay, let's continue. Another example here. Let me see. So may mga definition niya, no? Yung convergence, it converges in 3 cases, no? Let's look again. Let's copy this particular case. Buti na lang may copy paste tong no? So it will fall on 3 different conditions. So this power series that we define. Okay, so it will fall on yan. Okay, so there are 3 cases here, no? In a case, we could held 3 cases here. Case number 1, we have a case 1 here. It converges for all values of x. For all x. So all values of x could be a potential convergent, meaning the limit for this particular limit for this particular series, power series. Number 2, converges for all value of x, or it could be it converges for all x in an open interval. Ibig sabihin may open interval siya depending on the value of c. So there is it's dependent on the value of c. Let me have a mathematical here. So the interval could be the c minus that constant r, no? Or it could be c plus r sub 1 around c. So nandun sa c may plus and minus. yung region. R is that region or that constant kung saan umiikot yung convergence. Kasi pag plinat mo to, parang bilog siya, parang area. Doon lang, ibig sabihin yan, yung area na makikita natin yung sum ng series. Okay, so it could be a plus and minus R sub 1 around the value of C. So crucial ang value ng C dyan, but not outside. It cannot be outside this particular area. It could just be a plus or minus to that C, but not outside of that area. But not outside. Outside the closed interval. No? So, ibig sabihin, pag yan nag-equal na, kasi etong C minus R, this corresponds to greater than. Tapos yung C plus 1, this corresponds to less than. Pag nag-greater than equal, hindi na siya kasama. Okay? So, katulad nito, yung negative 1, pag nag-equal yan, yung equal, hindi niya kasama yon. That's becoming a closed interval. Open lang siya. Okay? So, normally, dinedenote natin yan as a pair of parentheses. Pero kapag yan ay naging closed interval na, meaning kasama na mismo yung value na yon, yung sagad, hindi na siya kasama doon sa region of convergence, but not outside the closed interval. Tingnan natin closed interval. Yan, so, yan po, I'll be putting some Ngayon, dinedenote natin siya in mathematics as bracket. Ibig sabihin, kasama yung mismong value na yon. No? Mismong value na yon, bracket siya. Yan, so C plus. Yan, so close interval. So hindi kasama si close, si open lang. No? Yan. Kaya may dilemma yung close open eh. Pag kayo nagiging close sa isa't isa, nagiging open kayo sa isa't isa. Parang may problema sa mathematics pag gano'n eh, yung close open. O kaya when you open to somebody, you are becoming closer to him. Tama ba, Sir RC and Ma'am Gina? So, gano'n nangyari. Pero, sa mathematics, magkaiba yon. Hindi pwedeng ang close, isama mo rin sa open. Ayan. So, mananatiling close, yun lang yung sakop. Yung open, yun lang yung sakop ng convergence. Pag naging close na siya, hindi na pwede. Sa mathematics yun. No, pero sa relasyon, pwede yun. Maging close ka para maging open kayo sa isa't isa, or maging close kayo para maging open, o maging open kayo sa isa't isa, magiging close kayo. Okay, so may connection issue yung aking estudyante. So tuloy-tuloy lang tayo. Anyway, I have my 3 top chats here in your YouTube channel, no problem. So, ganyan yung condition. The third condition is that, teka nga, panoorin ko nga sa YouTube tong aking estudyante. Sa YouTube na lang siya sa manood kung hindi kaya din sa streaming ano. Andali Natatakpan na yung aking ano eh. Alright, so sige, tuloy lang tayo, no? Ma'am, pasensya na at ito talagang ating kasanayan kapag opo, pero okay naman, mababait naman po kami, madam. Mga math teachers, mababait po kami. Nakakahilo lang talaga minsan. Kasi meron tayong tinatawag na multiple intelligences eh. So meron tayo niyan. Nagkataon lang na mas incline tayo sa numerical. Yan, si Sir RC, numerical smart din yan. Meron namang iba na merong inclination into verbal intelligence or word smart. Naman. Yung iba naman, merong mga inclination into kinesthetic or movements or yan, yung mga movements na yan, mga physical smarts. No? Marami po yan, maraming mga inclinations. Pero hindi nangangahulugan na kapag hindi ka magaling sa math ay hindi ka na marunong. Mali po yun. There's what we call a multiple intelligence as far as individual is concerned. Nagkataon lang na yung inclination ng isa ay doon sa numerical. So there must be some numerical smart. Yung iba naman verbal, magaling sa conversation, sa language, no? So they have word smart. Some may have smart as far as space is concerned. So spatial. Magaling siya sa mga construction, something like that. Some may have being smart as far as to communication to others. Ang tawag dyan ay or interpersonal, no? Or people smart. May mga ganong smart. Ito yung mga street smart eh. Ito yung mga matalino kahit nasa kalye. Madiskarte sa buhay. Yan yung tinatawag na street smart. Ayan po, marami pong klase. Marami pong klase actually. But really appreciate your madam, comment, no. So pero tayo pare-pareho, may mga kanya-kanyang being smart ang bawat tao, no? Yan po yung nahuhubog natin sa pagdating ng panahon, of course, with proper training as well and with proper guidance, no. Yung mga training na yan, experience in life. So ito mas humuhubog sa ating mga kalinangan bilang isang individual na tao. Right? So, yan po mga kapatid. And then we have number 3. Aside from this, it converges in all values of x. Lahat ng values ng x, pwede. Positive infinity o negative infinity. Pero may mga bagay na minsan number 2, nandun lang siya sa interval nung c. Either plus or minus r sub 1. And then number 3, meron pa tayong second category here. Or third category, it is converges, or it has limit, I would say. Converges only for x is equal to c. Kapag ang x equal to c, now there is a value. Alright? So these are the 3 cases holds for a power series of this case where summation of a sub n is times x minus c raised to n stands. All right, let's continue on this. Now we will have some sample here. Now we could test the interval of convergence. No, yung tinatawag origin of convergence, no? Region in terms of r, or it could be radius or of convergence or region of convergence, no, for this case, no. So okay lang po yan, no. Ibig sabihin po niyan, in other words, ito po ang katumbas po nito ay infinity. Kung itutumbas po natin yung number 1, yan po ay infinity. Ayan po. Kung itutumbas naman natin yung kanina, yan po ay yung c minus r sub 1. Yan po ay r sub 1 lang actually. So this is r sub 1. Okay, and then if there are cases that it converges only for x equal to c and such that c is equal to 0, so it follows that in case letter c at x equal to 0, pag in-equate mo yan, 0 talaga yan. So this would be also equal to 0. So it could be any values. The convergence of a power series could be infinity, meaning lahat for all values, hold for all values of x. We could define the series. Or perhaps there are certain values of r sub 1 in reference to the value of c. And thirdly, we have x is equal to c. So therefore, 0. So magsisentro siya doon sa value ng c. No? But normally, we equate it into 0. Okay, let's have an example here. No? For instance, we have an example, number 2. So we will, ang problem naman kasi dito, hindi yung mismong series, kundi yung interval of convergence. Sometimes we call it region, no? Region, or sometimes or radius of convergence, or interval of convergence. Convergence. Sana tama na spelling ko. Convergence. Yan, naalala ko na yung spelling. Yan. So yan naman ang issue dyan eh. Ano ba yung saklaw ng values ng power series? Yan naman yung issue dyan eh. Acknowledging for top chats on our YouTube channel. Thank you. No? Ano yung saklaw niyan? It could be either infinity on both sides, positive and negative. It could be a certain value R, or it could be 0. No? Ibig sabihin, kung i-graph mo yan, ang infinity, eto, may drawing, pwede pala mag-drawing. Okay, magdo-drawing tayo. Yung case number 1, pwede nating i-drawing yan, no? Since dahil at infinity siya, no, so pwede natin siyang, no, at infinity, anong drawing yan? Ang drawing ng ganito, it will correspond to the halimbawa, ito yung Cartesian plane, no? Pag infinity, ganito ang mangyayari dyan, guys. Pag infinity, all values. Ibig sabihin, lahat yan sakop. Infinity eh. Either both ends or sakop lahat yan, guys. So wala kang titira dyan. So yan ang ibig sabihin ng infinity. So lahat ng nasa Cartesian plane, pasok doon sa limitation ng series. So hindi talaga siya limitation kasi all values are potential eh. Potential value siya eh, no? Okay, so mamaya na tong illustration natin. So ganun po siya. And then ano naman yung number 2, yung values of R. So yung R sub 1. Sige, drawing natin siya. Yung R sub 1. Alright. So ito po yan. Hindi lang magaling mag-drawing talaga eh. Ang pangit ng drawing ko, guys, no? Pero nagigets nyo naman yung infinity, all values possible, no? All values, yung definition natin, converges for all values of x, infinity, no? So of course, may corresponding value of y pa rin yan. Pero pagdating naman sa R sub 1, meaning it could be both positive or negative, assuming we have the center as the value of x. Sige, drawing tayo para mas concrete. Kasi minsan kailangan makita eh. Drawing ako dito. Cartesian plane ulit. Okay, ang value ng C mo halimbawa ito. So meron kang region of R. Yan yung magiging radius mo. Alright. Acknowledging Jan Music TV. Salamat, sir. Opo. Estudyante ngayon si Mami Gina nandito sa Sir RC Pinoy. Welcome sa inyo. My student has problem in connection. Ayan, teka, pumasok siya. I think my student is coming in.
Po.
Good morning, Joshua. Welcome.
Sir, Dale po.
Dale nga pala, magkapatid pala. Nakakalimutan ko. Welcome, Dale. Thank you for dropping by. No, we are into power series. This is an important topic. By the way, next week will be your midterm exam, and our midterm is in oral format. I'll be asking question. Mahirap talaga ang connection dyan, Dale.
Sa ngayon, sir, opo, kasi malakas po ang ulan. Hindi po ako makalabas doon sa open field gawa po ng maulan po.
Mas malakas yung signal, no? But nevertheless, you prepare by next week. Also the same time. Later on, we will have a session for modern geometry also. Oral ako. So magtatanong ako ng I'll give you time to answer, to explain your... Then you will be graded based on the accuracy of your answer, solution presented. At the same time, your manner of how you communicate your answers properly. So those are the two aspects that I'll be looking. The coverage is starting from series, sequence, and this one, power series as well. So yan yung mga coverage natin. So we will maximize 1.5 hours for that, for that next week. So that will be your week number 12, and that's your midterm examination. Okay din, so be ready.
Okay po, sir. Okay po.
Review mo na lang yung mga videos, lecture notes, no? Pati ito, upload ko mamaya. So hopefully, no, I could upload this. Now we are now in the region of convergence, of radius of convergence. Okay? Later on, balikan na lang yung siguro previous. Now, though I'm just starting the power series definition, no? Which is somewhat related to your geometric series. No? Napag-aralan na natin geometric series. Now, kapag infinity, everything is covered, all values of x. Now, for region, assuming that you have a C here, you have your, teka, nasa drawing mode ba? Okay, this is your value of C. No? It could be plus or minus. So, this is your minus, your C, minus R sub 1. And let me extend this. And then you have here, say, ito yung value na yan. You have C plus R sub 1. Okay. Now, if you would draw the circle, that would determine now the into shape ako siguro. Yun. This would be now what we call, teka, ayaw niyong madrag, no? Mali ako dun, Mali ako ng drawing. Teka. Tapos eh. Baguhin natin yung ano. Yan. Ayun lang. Anyway, sige, ano ko na lang to. Paano ba ito medyo weird, nawiwirduhan ako dito. Okay. So, assuming that this is, ito yung values niya, no? So, this is what we call now the region of convergence, of the radius or of convergence. Or sometimes we call it the interval of convergence. So, within that circle, within that region or radius, pasok yung values ng power series. Meaning, nandyan yung convergence area niya. Nandyan yung convergence niya. Opo, noted, Ma'am Gina. Salamat po sa pagdalaw, Madam, ha. Ma'am, i-post nyo, Ma'am, ha. I-post nyo yung pagkain nyo sa YouTube. So, meaning, on this particular area, no, meron kang define yung ano mo, yung power series mo. Alright? So, define yung power series mo on this area. Pag lumagpas dyan, divergent na siya, Dale.
Opo.
Okay? So, ganyan yung sense niya. Now, yung pangatlong case, yung sinasabi natin kanina, yung pangatlong case, tuldok na lang yun. Kasi nga, yung third case natin, case number 3, 0. No? Yung 0. So, kung anong value ng C, yun lang yung, pag lumagpas dun sa tuldok na yun, divergent na siya. Yun yung mangyayari doon ngayon, no? So, if I would redraw this, halimbawa, ito yung Cartesian plane mo, ito yung value of C mo, dyan lang siya. Ito na mismo yung region of convergence mo, no? Pag lumagpas dun sa tuldok na yon, divergent na siya. So, ganun yung mangyayaring implication dyan. No? So, meaning, so this is the area, the region. This value now is your region. Region of convergence or radius of convergence mo. Dahil 0 siya, tuldok lang yung, pag lumagpas dun sa tuldok or that point, so ito yung magiging area of convergence mo, no? or yung region, the R. So yan lang yan. Yun na rin mismo yung pula. Okay, pag lumagpas dyan, divergent na siya. Alright, so that's the geometrical illustration for our three cases. First case, it converge for all values of x as illustrated on this first illustration. And it has, for number 2, it converge at this particular value c minus r sub 1 or c plus r sub 1. We did that range, but hindi kasama yung mismong bilog. Hindi siya close interval Dale, open lang siya. Yung mga punto sa loob ng bilog, hindi kasama yung linya ng bilog. Alright? So that's what we call open interval. Open interval, but not outside the closed interval. So hindi kasama yung closed interval kasi magiging labas siya doon. And then the third one is just a dot. O if this would be the value of your C, so be it. So this would be your C. Alright? So yun yung makikita natin doon. Now, let's look at another example here of a power series. No? Now, the main issue for this power series problem is to know the interval or the radius of convergence. So yan yung Dale yung titingnan mo dito. Ano ba yung radius? Ano ba yung scope ng values ng X na kung saan may convergent yung power series, hindi siya divergent. So let's look at this, examine this example. No? So as I'll be writing this in the mathematical editor. Uy, nawala. Ano nangyari? Pwede yan. Nagkamali yata ako. Right. So, yan. So, what we have here, ayaw niya akong lubasan dun. Okay, so anyway. Anyway, assuming nawala yung summation dun sa ano ayun, hindi magawa. Ulit. Alright. So may mga glitches pa rin sa pagka-type ng ano. Yun, okay, good. Okay, Dale, can you see the expression, example 2? Nako, nahulog si estudyante. Okay, Sir RC, are you still there? Or Sir John, can you give me the first term of this power series? Sir RC, if you're still there. What's the first term? Kung nakikinig ka, Sir RC. Or Sir John Music. Kasi si Ma'am Gina magluluto na. Ano kaya yung first term nito? Okay. As we substitute n is equal to 1, what would be the value? So it must be just x minus 2 raised to 1 is x minus 2 plus what would be the next term? So x minus 2 squared, dahil at n is equal to 2 nang gagamitin natin, all over 2. Yan. Plus, so you have x minus 2 cube, and then you have over 3, and then etc. and etc. Alright, so that would be the expansion. That would be the expansion of this power series that we have here. No? So, ayan, may problem talaga yung sa estudyante ko. So now the question here is, what is the interval of convergence or the radius of convergence? Now, what are the potential values of x where the power series is converging? So we have here a test, a ratio test na tinatawag as a matter of example here. So we have a ratio test, and the ratio test is actually defined by this as the absolute value. Yan. The ratio test is defined by the absolute value of the sum, the partial sum, n plus 1, all over n sub n. Yan. So, all right. So that's the definition. So that's the definition of the ratio test. That we have here. So we could apply that here. So what could be the partial sum n plus 1? What would be the partial sum? Of course, the partial sum, we just need to substitute. No? There must be a substitution here. No? Obviously, kung kukunin natin dun sa definition ng expression, if n is n plus 2 raised to n plus 1 is definitely n minus 2 raised to n plus 1. That would be the case. So if that would be the case, your partial sum n plus 2, okay, would be equal to absolute value again. Absolute value of n minus 2, okay, raised to, this would become n plus 1, all right? And then all over, of course, we have n plus 1. Yan. And this needs to be divided. Now we will divide kasi masyadong malawak pag ano, no? Div. All right. So divided by the normal sum, partial sum s sub 1, we will just copy what is the definition for this case. So from here, so we could say that this is, ayan, ano lang yan, kopyahin lang natin. Minus 2, absolute value. All right, so you have raised to n. Okay, all over n. Yan, so yan yung makikita natin dyan. Of course, there will be cancellation here. If you will see, the n minus 2 raised to n plus 1 absolute value divided by, so, sige, ano natin to? Simplify natin to. Siyempre, to divide, you just get the reciprocal, no? Tama ba? Reciprocal. Okay, reciprocal. Okay, thank you Dale. Thank you Dale for ito yung estudyante ko kanina. Thank you, sige. Okay. Kung mas okay sa YouTube, dito ka diyan ka na lang Dale. Walang problema. Okay. Yeah. So, we understand the connection issues. Wala ka pa palang jacket sa akin Dale, no? Lalagyan muna kita ng jacket. Dale is my student, math major, third year. Yan, so okay lang yan. So let's continue. No? Pero okay lang mag-chat-chat ka dyan kahit medyo delay. Okay lang yon. I would acknowledge that. So from here, so pwede natin siyang kunin yung reciprocal ng divisor para magamit mo yung multiplication. Yun yung... Pero dito ko lang gagawin yan So I will just copy this. Then, instead of that, we will times, multiply. Okay? Multiply natin yung reciprocal ng divisor. Ano yung maging reciprocal ng divisor? N all over. So you have absolute value n minus 2. Okay? Raised to raised to n. Yes. Yan. Okay? So there will be a sort of cancellation here. Magkakaroon tayo ng cancellation dyan. Of course, ang matitira na lang ay yung constant. Yung constant na lang. Unahin na natin yung constant. N all over n plus 1. Yan po yung constant. Yung loss of exponent. So matitira dyan ay n minus 2 na lang. Kasi n minus 2 raised to n plus 1 divided by n minus 2 raised to n minus 2 raised to 1 ang matitira. So therefore, this would be equivalent to n minus 2. No? Absolute value. N minus 2. Yan. N minus 2. Alright. So, hindi pa tapos. Wala pa tayo sa katotohanan. So, kasi we're using here the ratio test to find for the interval of convergence and we will get the limit. And the limit is approaching infinity. No? Infinity to. So, infinity yan. So, we will get the limit of such value. Siguro dito na lang. Limit as n approaching okay, mali ako. Positive infinity to, no? Yan. Limit as approaching infinity, your ratio. No, your ratio. Kakopy paste ko na lang to. Okay. So ano ngayon mangyayari dyan? So yung n minus 1 mo, so there'll be manipulation here. Yung n mo ngayon, i-divide mo ng over n. Hindi na siya kailangan dagdagan doon. Alright, so what you have here is actually limit of n, right? Doon. However, we could manipulate this such that we could manipulate that. Ay, hindi. That product. Mali. Ano nga ba yun? So anyway, we could manipulate that such that what you have here is 1 over n over 1 over n. So we could have some manipulation of that here. Yan. So of course, what would happen there? So of course, 1 of 1, then this will be reduced to 1. So matitira na lang dyan, ang punto ko dito, matitira na lang dyan, x minus 2, absolute value. Right? So we have here x minus 2, absolute value. So since we are defining this in terms of positive and negative 1, so yung ating ratio kanina, hindi siya lalagpas doon sa definition natin ng convergence, no? Negative 1 up to positive 1. So that if that would be the case, you will apply it here such that if that would be the case, no? If that would be the case, so magiging convergent natin diyan, negative 1 less than x minus 2. Pag tinanggalan natin yung absolute value, x minus 2 less than 1. Alright? So what would be the case? We could still manipulate this, adding 2 to neutralize for the values of x. So it follows, so this would follow that if you will add 2 to this, so what you will have? So you have 1 less than 3, less than x, no? And 3. Okay? Okay, acknowledging G Lalab, salamat po sa iyo, madam. Okay, nakitan ko yung ninja number 8. Yan, so jakita natin si madam. Salamat madam sa iyong pagpunta. Dahil dyan meron kang jacket. So in representation, the region of interval or region of convergence, ROC now, or radius of convergence is actually equal to 1, 3. Okay, 1, 3. So close interval yan, hindi open interval, hindi siya close interval, okay? So yan yung makikita natin diyan. All right. So okay, let's continue here. Hanap ako ng iba pang sample problem siguro dito. All right. So we have a sample problem. Dale, are you still there in the YouTube channel, Dale? Paramdam ka, Dale, para ano. So kung may katanong ka, okay, another example here. Example number 3. Okay, so given here, find the interval of convergence of the power series defined here. So, sige. Talaga nakakalito to, Dale. Kaya kailangan medyo basa-basa ka. Ayan, ito. Kaya meron pa tayong mga sample problem. Saan galing yung negative 3? Dinagdag mo yung Dale, nagdagdag ka ng dalawa. So, negative 1 plus 2 is 1. X minus 2 plus 2 is X. 1 plus 2 is 3. So, ito yun, Dale. O, teka. Sige, i-detalye natin. So, negative 1 negative 1 plus 2. Right? So, you have X minus 2 plus 2. Okay? And then you have a 1 plus 2. O, solve mo yan. O, yan, no? Para ma-solve yung X, Dale, inequality tayo. No, we are solving X both on the left and the right side. What you have done in the left, you do on the right, you do also on the middle. Yan, yun po yan. Alright? Okay, let's move on. Find the interval of convergence. No? So, ito yung given series. No? Okay, sigma. Okay, so this is the definition. X, hindi ko na siya i-expand, Okay, so find the interval of convergence of x minus 2 raised to n all over x over n. So that's the question. Okay, that's the question. Okay, by inspection, we could say na halos pareho lang siya nung kanina actually. Medyo, ay pareho pala dapat, pareho. Teka, mali. Pareho yung aking dito. Hindi, mali pala yung nakuha ko. Teka lang, wait. Iba yung nabasa kong problem dito. Ito, meron pala. Okay. So, mali pala ako. Mali ako ng kopya. Dali lang. Okay, ito lang pala siya. Okay, so this is the power series, no? Summation of x raised to n all over n squared when n is equal to 1 up to infinity. Hindi, ang right arrow, ibig sabihin niyan yung nangyari, Dale. Hindi siya equal. I cannot make it equal kasi hindi naman talaga equal. Hindi siya equal. It's a progress. It follows, no? It follows, no? So yung arrow dito indicative na may ginawa ka doon sa previous. No? So kaya linagyan natin ng arrow. Pero not necessary yan. Not necessary na ayan, yan yung ating Okay, let's move on with the second problem or third problem we have. Okay, so we could expand this first, no? expansion nito. No, anong expansion? X first term plus anong second term? X raised to 2 all over 4. That's the second term. Plus x cubed all over 9, etc. and etc. Okay, so that would be the expansion. All right. Now the question is, what is the interval of convergence? What's the interval of convergence for this case? All right. So what's the interval of convergence? All right. Noted, Dean, no? So obviously by inspection, no, by based on the definition of this one, or using ratio test, okay. So what would be your for that case? That would be x raised to n plus 1 all over n plus 1 squared. Yan. So yan yung makikita natin dyan. Divided by of course, we have x raised to n all over n squared. Okay. So from here, paikliin na natin. So ano ngayon magiging ano natin dyan? Acknowledging 4 top chats from our YouTube channel. Thank you. Welcome to our Calculus 3 class. So from here, there will be some cancellation. Ang matitira na lang sa x raised to n plus 1 divided by x raised to n is obviously x. Pero doon sa constant, so ano yung may iwan dyan? So ang may iwan dyan ay n squared all over n plus 1. Okay? And then absolute value of x. From this case, we know that the limit at n squared all over n plus 1 squared is equal to 1. So this must be equal to absolute value of x. And if we will try to put it in a convergent, no, this would imply what? Imply that this is 1 greater than x, negative 1 rather, negative 1 greater than x, greater than 1, or less than 1, I would say. All right? So that would be the region of convergence. Okay, Dale, do you copy? So yan, no, marami pang iba dito eh. Kaya lang, we don't want to dig further. So bibigyan kita ng mga screenshots ng problems, Dale, na pwede mong sagutin. From time to time, let's move on. No, Okay, another ratio test. Example 4. Using, okay. Again, solve for the interval of convergence for this case. So we have sigma na lang, no? Understood na yung value nito, ah. Okay. Palakin ko nga ito. What would be? So we could solve for the using the ratio test again, no? For this series, we make use of the ratio test, using again the ratio test. Ratio test. Okay. So of course, what is partial sum n plus 1? So obviously, what would be the case there? So medyo komplikado lang siya. Okay, so you have n plus 1, okay, multiplied by absolute value. Okay, we could have that absolute value of x raised to n plus 1. All right, then we have divided by this quantity n plus 1. All right, so that would be the case divided by, okay, divided by s sub n. And obviously, your s sub n is equal to n times the absolute value of x raised to n, right? All over, this would be all over 10 raised to n. All right, sige, solve, Dale. Also, by definition, by limit. No, obviously, ang mangyayari dyan, yung limit natin, the end result, you may verify it further. No? The end result would be absolute value of, of x all over 10. Alright? So, yan yung definition niya. So, from there, pwede natin siyang kunin yung ano niya, interval niya, no? Okay, so from here, right? So anong implication nito? Implication, multiplying 10, no? Anong mangyari diyan? So negative 10 x, sana pala tong ano, absolute value. X na lang to. And then positive 10. Okay, that's the region or interval of convergence. All right? Do you have question before we continue? We still have few time to introduce Maclaurin Series. So, hugutin natin siya sa definition natin kanina that for your Maclaurins at C, any value of C, but for Taylors at F is equal to 0, C is equal to 0. No? So, yun yung makita natin dyan. Okay, so let's continue. No? So, I will just plug in the definition here of our power series. So this is the definition of power series, which will be our basis for our Maclaurins. Right? Then of course, at C is equal to 0, so yan yung Taylors natin. So magiging ano na lang to, x raised to n na lang. Is equal to x. Yan, etc. and etc. So yan yung dalawang bagay na yan. No? Na example here, on the Maclaurin series, example 5, so I'll be dealing with this, no? No worries about the definition. So it's actually a definition of the derivative. Now we are actually making a derivative or a constant, no? Based on this definition, by the way, yung a sub n dyan is actually your f of n of 0, okay, all over n factorial. So that's the for all values of so yung a sub n mo kukunin mo depende sa kung ilan yung terms na ipoproduce ng power series. Ayan. So ayan, for all values of all n. Okay? That's a sub n. So meaning, yung f of n term, that's the derivative. Now, derivative yan. Yan yung derivative. No? So meaning, example, yung a sub 0, kukunin natin yung mga constants. No? We will define the constants. Yung a sub 0, paano mo i-define yung a sub 0? Pareho lang siya. So, constant of f0 over 0 factorial. Of course, 0 factorial is equal to 1. So, this is equal to f of 0. Alright? So, next to that, definition, your a sub 1. You define a sub 1. Kasi constants, i-define natin yung mga constants dito. Ayan, i-define natin yung mga constants in terms of its derivatives. Ayan. So, yung a sub 1 is equal to yan, f of prime of 0 all over 1 factorial. No? Obviously, this is f of 1 of 0. O ibig sabihin, derivative of a function at x is equal to 0. So, yun yung ibig niya sabihin diyan, no? Yan. Kasi 1 factorial is still, ano, no? How about double prime? How about double prime? The double prime, this is now 2 factorial. So, hanggang dyan na lang yan, no? So 2 factorial, no? Etc. and etc. So A sub 2 to. Okay, acknowledging. Ma'am Ilocana Inday, salamat po, madam. Ma'am Churcher, salamat. Welcome to my Calculus 3 class. Salamat, madam. May live na ba tayo mamaya, madam? Salamat. Yan. So, nandiyan pa pala Sir RC. Alright? So, here, so, etc. and etc. to, it follows A sub 3 is triple derivative of function at x equal to 0 all over 3 factorial, etc. and etc. So, ganun yung mangyayari dyan. No? So, let's have an example to concretize this. Pag walang example, malabong maunawaan. Bibigyan natin ng example. What is the Maclaurins? What is the Maclaurin series for sine of x? Yan yung problema natin ngayon. No? Oh, yung right arrow. Yes. Yun lang yun din. Walang ano doon, walang confusion doon. Di ka dapat ma-confuse doon. Wala yan. Ibig sabihin, may progress yung ginawa natin. Hindi kasi pwedeng equal eh. Hindi pwedeng equal kasi meron kang inequality sa gitna. Magkakagulo. Alright? So, kaya ginagawa natin ay arrow sign na lang. Okay, anyway, let's focus here. So, the Maclaurin series. Ang kailangan natin gawin, guys, hanggang third or fourth derivative, siguro hanggang so ang magiging discarte natin diyan, let f of x is equal to sine of x. Alright? So yan yung assumption natin diyan. So kasi hinahanap natin yung Maclaurin series, ilalapat natin dito. Ilalapat natin mamaya diyan. Yan, ilalapat natin siya dito. Right? So now what would be the next thing here is to solve for the first derivative, f of prime of x. That's the f of prime of x now. F of prime of x is actually the derivative of sine of x. And what's the derivative of sine of x? Of course, this is cosine of x. And cosine of x. Alright? So yan muna ang titingnan natin. And it follows, mamaya na. Okay, derivative. So saka natin susolvein yung f of 0. F of prime. Kasi dito, solve na pala natin eh. It follows here that f of 0 is equal to sine 0. And what is sine 0? Obviously, this is 0. Obviously, no? So, yung constant wala ka kasi ano siya. No? So, yung constant mo wala. Sine 0 is equal to 0. So, yung first term actually wala. Yung a sub 0, wala kang a sub 0. Kasi nga, at f of 0, sine 0 is equal to 0. So, of course, from here, it follows that it follows that your f of prime of 0 is equivalent to cosine of 0. And what is cosine 0? What's cosine 0? It's equal to 1. Equal to 1. Yan. Alright, okay ba? Yan. So, salamat sa tatlong nandiyan pa rin. Yung aking estudyante at yung dalawa pa. Salamat sa inyo. Alright. So, yung f of prime of 0. Yan yung kokopyahin natin maya-maya eh. Kaya lang, kailangan nating solvein yung iba pa. Okay. So, titingnan. May pattern naman to. Huwag tayo mag-alala. So, f of double prime now, or the second derivative, is actually the derivative of the derivative, second derivative, no? So ito ay derivative of the derivative. Tama? So instead of sine of x here, kukunin natin yung derivative ng cosine kasi siya yung sagot dun sa una. And you know what's the answer here is negative sine of x. Negative sine of x. If that would be the case, the f of a double derivative of 0 at x equal to 0, so what would be the case now? So negative sine of 0 is obviously equal to 0. Okay? So sine 0 is equal to 0. Umulit siya. Tingnan natin, no? Okay, how about the third one, the third derivative? So dadagdagan ko lang siguro to. Ito yung derivative yan, para medyo ma-recall natin ng konti. Yan, basta ang na-compute natin guys sa ito, yung kanina, yung f of x sin x, f of 0 is 0. That's 1. And then f of prime of x, cosine of x, f of prime of 0 is equal to 1 because cosine 0 is equal to 1. Next to that, okay, f double prime of x is equal to negative sine of x. Therefore, at x equal to 0, no, negative sine 0 is equal to 0 as well. So nagkakaroon na tayo ng pattern guys, no? Kakaroon na tayo ng pattern dito. Then, next, siguro hanggang tatlo lang. F of triple prime of x is equal to, of course, yung derivative ng f double prime of x. O ano man yung sunod doon, no? Which is actually equal to the derivative of negative sine of x. Yan. And what's that? That is negative cosine x. Then we could solve for the f triple prime of 0 for this case. So substituting now here, all right? So we have here 0. So this would mean negative cosine 0. And what is negative cosine? Alright? Oh, what's negative cosine of 0? Cosine 0 is 1, so therefore negative 1 is the answer. Negative 1. Right? Okay, negative 1. So we could hear the pattern 0, 1, 0, negative 1, and then 0, 1 again, 0, negative 1, 0, 0, negative 1. Ulit, 0, 1, 0, negative 1, 0, 1, 0, negative 1. So there could be a pattern. No, yan yung pattern natin. Alright? Kung ilalapat ngayon natin, so ngayon, in summary, what would be summary? In summary, what is f of 0? It's 0. Okay? What is f of prime of 0? Okay? Ano yung f of prime of 0 natin? Is 1. And what is f of double prime of 0? No? Ano yan? Is 0. Then what is f triple prime of 0? As we have here, okay, is negative 1 and so on. So yan yung magiging pattern niya. Kasi pag kinuha mo pa yan, yung derivative ng negative cosine, magiging sine uli siya. Babalik siya doon sa una. So positive sign yon. 0 na naman. And then, uulit na naman yung prime. No? So, yan ay magiging yung pattern natin. Okay? Now, substituting from this definition, expressing now, mula doon sa a sub 0, so ano ngayon yung a sub 0 mo? A sub 0, kasi f of prime is 0, yan. Is actually based on the definition, yan, f of 0 over n factorial. Dito natin kukunin yung definition natin, guys. Yan, hili-hilira na to. Okay, based from that, it follows, how about of course, it follows that since your f of 0 is 0, automatically, a sub 0 is equal to 0. Ano pa yung 0, guys? Alternate to eh. So, hindi na natin pahabain yung a sub 2. A sub 2 is also equal to 0 because your second derivative is equal to 0. It follows that the constant is equal to 0. And it follows through with a sub 4. O, mabilis na, di ba? Yung add na lang ang problemahin natin. A sub 4, it follows equal to 0 din kasi nga 0 yung constant nila. Ngayon, ang magiging problema na lang natin, yung, since, by the way, sign is actually an odd. It's an odd function. No? Dito natin makikita yung pagka-add nung sign. No? O, a sub 1 natin. Ano yung a sub 1? A sub 1 is equal to, salpak natin. O, balik tayo dito. Is 1. 1 over n factorial. Or 1 factorial rather. Diba? So, of course, yung x, ng value of x. Sorry, my mistake. Kakibat niyan yung x. X. Kasi yung counterpart nito yung x. Yan, equal to 1. Yan. How about a sub 3? A sub 3, ano yung a sub 3 natin? Negative 1. So yung a sub 3, negative 1 yung f of prime niya. F of triple prime. At 0, it's negative 1 all over 3 factorial. Alright? Then babalik siya. Pagdating sa a sub 5, guys, babalik uli yan sa a sub 1. Babalik uli yan. Yan. So that would become, so of course, yes, this is, as is na natin to. Babalik siya 1 over 5 factorial. Etc. na yan. No? Pwede pa natin pahabain yan, a sub 7. A sub 7, so following the pattern, so magiging negative uli siya. So negative 1 all over 7 factorial, etc. O yan, susundan pala ni Dale. Okay. So from there, we could substitute now the definition of this one. Plug in natin to. Plug in natin. Yan. Of course, yung mga even functions, yung mga even, wala yan. Puro zero na yan. Alright? So ang matitira na lang dito, doon sa sign of x natin, as the Maclaurin series stated, would be 1 times x. Kasi x sub 1 tayo, x na lang yan. And then susunod na term ay a sub 3 minus, will take a minus, no? It will take a minus and a power of 3, x cubed over 3 factorial. Kasi pag binugtong pa natin dito, yung a sub 3 natin, a sub 3, magiging x cube yun. X cube. Etc. Okay? Pag tinuloy pa natin, plus, anong plus x raised to 5 all over 5 factorial. Then pag tinuloy pa natin, minus x raised to 7 all over 7 factorial. Yan, etc. and etc. So that's now the Maclaurin series. Okay? Sige, we will continue this. Wala na pala. Hanggang dito lang, Dale. So I would suggest for you to derive the Maclaurin series of common trigonometric functions and common exponential functions. So yan, bahagi yan ng ano. So ito na yung Maclaurin series ng sin of x. Okay? So yan muna tayo. Hanggang dyan muna tayo. Ayan, alam kong medyo gutom na kahit masakit na ulo natin. Nevertheless, ayan, so yan yung ating, so far we have discussed power series, then we'll introduce the Maclaurin series. That's part of the power series, but the definition of the constants is through the derivative, series of derivatives as we have seen here, and then we just substitute. Okay, for here we have seen that sine is an odd function, an alternate positive, negative function. Okay, so we thank the Lord for that. Okay, so alright, so salamat sa Panginoon. I hope na Dale, okay ka pa. So yan yung atin, no? So mag-derive ka pa, no? Derivation ng Maclaurin series of common functions, no? Trigo function, exponential, logarithmic, no? You may solve the Maclaurin series of that. Hindi, batay ang Maclaurin sa power, hindi sa geometric. Nagkataon lang na yung power series geometric, pero magkaiba sila. Alright? So, magkaibang ano yun, magkaibang aspect. Ang lumabas dito, hindi na siya geometric. Power series talaga siya. Power series siya. Okay, yung may naka-highlight dyan. It's the power series or the Maclaurin series of the sign of X from the power series definition. Not necessarily geometric. Kanina lang yun yung geometric kasi pinag-aaralan natin yung kanyang interval. Yung kanyang interval dito. So, most likely, at saka yung ano niya, so dapat, pag converging siya, geometric series siya dapat. Converging. When it is a converging series, it must be a geometric series para ma-define natin kung ano yung radius of convergence na tinatawag. Doon lang yun. Pero ang iba pang gamit ng power series ay yung Maclaurin series for specific type of functions. Where for this case, we have demonstrate the function or the Maclaurin series of sin of x. In fact, this is true for radiant measurement. It's not, magkakamali yan kapag degrees ang sinubstitute natin. It must be from radians measurement. Right? So anyway, sige. Chat na lang Dale in due time. Okay? So later on, 1 or 1:30, we'll resume our modern geometry class. Okay? May iba ang papagawa sa geometry. Not necessarily the same as our calculus 3. Okay? Sige, let's close in a word of prayer. We thank the Lord for this time. Thank you, Dale, no? Even though you are not in here, nasa YouTube ka, no? Thank you. So let's close in a word of prayer. Father in heaven, we thank you for this day. Thank you for this time that we may have the nitty-gritty of our series, including the Maclaurins, sooner or later Taylor series. I pray, Lord, that we may look into this as it has application also in signal processing. It has application in most of the communication systems now. This series that will evolve into more complicated sequences such as Fourier series, Laplace transform, and other things, Lord. But nevertheless, these are basic types of series where we could solve and we could have appreciation of this solution, Lord. We thank you for the life of Dale, even for the rest of our friends who are tuning in here in our YouTube channel. We thank you. We glorify your name. It's our prayer in Christ's name. Amen. Okay, thank you so much. We will continue by later on, 1 p.m., 1 or 1:15 Dale, we will continue on our, radian measurements. We will continue on our modern geometry. Okay? So God bless us all. And see you Dale later by 1:15. So,